Good day to you. This is our third presentation in conjugality, where we're now going to define it. The universal reference frame is a goal of science. Einstein was attempting to achieve a universal reference frame. As you know, he began with a special reference frame and then went on to generalize that to create spacetime. The way it's used, it should be called Einsteinian spacetime because Einstein made a very specific formulation, and it is linear geometry. So it's derivative. He got the linear solution to a spherical problem. The universal reference frame, as I discovered, can be derived by induction, essentially based off of the Einstein field equation approach, which is a geometry using four lines, as you know. The signature is strange, so it doesn't exactly work because it's linear. You can't solve a spherical problem with linear algebra. I proved that. It's really always been known, and even the discoverers of the calculus admitted that they were not getting geometric solutions. They're getting mathematical solutions, which is approximate. That is unacceptable. It simply doesn't work. And we discovered that in cosmology. And we also discovered it in quantum mechanics. And that's why both of those edges of physics are halted. It's because the mathematics won't support a solution. However, I proved in 2022 that there is an intrinsic geometry that solves for the calculus, so that instead of using a derivative in order to get a linear solution, you can integrate the solution space. And that's called spherical geometry. It uses a two-component number system. It's based on orthogonality, which transposes to linear systematic space, as you know, because a 2D surface called a plane could be parameterized either with a straight or with a circle. And nobody ever has tried the circle. A remarkable statement that the plane on which all of Euclidean geometry and essentially all of mathematics is based on a Cartesian plane, which wasn't actually discovered until René Descartes and a couple of cohorts. Discoveries of this nature tend to be discovered simultaneously by several men at once. And it's so well known that it's inescapable. It seems anomalous because it seems coincidental or synchronistic. That, for instance, Newton invented the calculus exactly at the same time that Leibniz did. And neither one of them knew of each other's work, although there's an historical footnote which turns into a soap opera. But the fact is neither one of them knew of the other one's work with the calculus. So what was the calculus? A brilliant attempt to solve an interdimensional problem, because linear algebra cannot address curvature at all. I proved that in 2022, so it's a known fact that curvature simply will not conform. And there's a number that expresses the discontinuity between the two systems of the straight line, which is Euclidean geometry and Euclidean mathematics, ultimately Euclidean logic as well. That's based on the straight line, but not really. And you should not begin with a straight line, although axiomatically you have to. And as Euclid proved so well, in order to begin axiomatically with just a single line, you must define the point first. And I've been over that so many times, I don't need to summarize that. You probably can guess that when you address the plane, that's your address space. It's not the line, which has no breadth or height. It's missing two of the dimensions of real space. So the line is a derivative object of some higher space. In 2022, I proved conclusively, for the first time in human history, in mathematics or physics, or in fact in geometry, that there's a fixed relationship between linear space which we call Euclidean space, because it's linear. That's why it's Euclidean. It's because it's based on the parameterization of the plane with two lines. Two lines. And you can't start with a line. You have to start with a plane. And in fact, when you draw a line, which is the first thing Euclid tried to do, but first he invented the point, so that his line would have two ends. At least one end called the origin. That's called 0 now. But in Euclid's day, he stated it geometrically, that it has no existence. So he invented something that does not exist, and it's defined that way. It's the smallest spatial object that you can invent, and it's so small that it doesn't exist at all. But retroactively, you can go back using Cartesian planar approach and say that that point is a position. And then it does make sense, but only in terms of add, only in terms of linear spatial separation, only in terms of distance, only in terms of length. Let me repeat, only in terms of add. So that's a major discovery at the basis of arithmetic. I discovered the role of the two operators, and nobody has ever discovered that until I did. That add only applies to the line. Now you may think, what about subtraction? That's the inverse of addition, and you don't need it. The entire system is coherent for add. You don't need subtraction. So that's one space. That's one parameterization of the plane, is with two lines. That doesn't work because that's called extrinsic geometry. You applied a grid, which then turns into a cubic grid with volume space. And then it turns into a hypercubic grid for spacetime. But you know that spacetime is based on curvature. That's the entire principle that's being approached, is curvature itself. And so the calculus had to be extended. And this is Einstein's great breakthrough in algebra, that he extended the Newtonian tool. You could forget Leibniz. It was Newton who invented the calculus. Leibniz kind of got it, but Newton is the one who discovered it. There's no question about that any longer. Newton discovered the calculus. And here's the reason why. He applied it. Leibniz did not. Leibniz did not apply the calculus to any practical problem. He was a philosopher, and he went after the monad concept, which leaves him in the dust, because Newton practiced actual discovery science. He used the calculus, which proves that it has a use. It certainly does. But Newton could not have foreseen Einstein. Einstein understood the calculus well enough under a teacher for 10 years. Between his release of special relativity in 1905 and his release of general relativity 10 years later, he studied under an algebra expert and learned the calculus so well that he extended it to something that I named because it requires a name. It's hypercalculus. And I've given several videos on that so you can explore that yourself, so that if you're willing to take the dare, you can actually learn about general relativity, space-time, and the Einstein field equation by exploring the Einstein field equation under an accredited master. I don't know the man's name, but he's immortal in my book. It's Dr. Physics A. You can look him up. I have several videos on his exploration of the Einstein field equation. I had to watch his 3-hour video series twice to be sure that I understood the first time. It's a good thing I watched it twice. The Einstein field equation is one of the most difficult to understand equations of all time. You might say, oh my God, no, you're so naive. Am I? Did I leave anything out? Sure. The wave equation in quantum mechanics is equally difficult. And it's difficult to gauge which one is more difficult. But they can easily be solved by transitioning to integral space, which I discovered. It's a numeric transformation. It's a mathematic and basic arithmetic transformation depending on several consecutive discoveries that I made in geometry whereby I was able to prove that the Euclidean plane is misparameterized. You cannot start with two lines. Now, there's an objection to that due to superposition. Because you know that the two-line construction, the parameterization of the infinite plane with two lines making x and y, it does work. It's called the linear solution for circular space, but that's exactly what it is, and that's what it should be called. Because in the 20th century, mathematical physics discovered that linear algebra is inadequate. It simply has a hole in it called a singularity. And I discovered several other flaws in the linear system, including the infinity of infinities of the irrational numbers, which I proved are not numbers. The universe uses positive quantities for everything it does. And I was able to show very easily, using conjugal space, which is the reason for bringing this up. Spherical space is based on circular space. Circular space has to be based on linear space because the linear space has the computable numbers. But the solution to that nasty problem, which produces pi is the death sentence. If you have to rationalize pi, well, nobody even ever thought of doing that. Nobody has ever tried to do that, ever. And I had to check, and this is part of a researcher's responsibility. Are you sure that nobody noticed that before? Yes. Nobody has ever noticed my major insight, which is at the foundation of science itself. You have the wrong number system. You're using illegitimate numbers. You're not using arithmetic right. You don't know the difference between add and subtract. You don't know the difference between add and multiply. And division has driven a stake right through your Dracula heart. And you can't solve anything now, and you know it. That's been proved empirically. Science is at a standstill. With respect to pushing the envelope, we have so much data now at the subatomic level that this should have been figured out geometrically by now. That discovery awaited my appearance in the science scene. So I am the greatest discoverer of modern times because I solved the Einstein field equation. And I also, in order to do that, had to reconstruct mathematics from the axiomatic basis right on up, to redefine the operators correctly, because add and multiply do not apply to the same space. Add only applies to linear space. And then you have to extrapolate to get a curve, and that leads to pi, because the relationship between the radius of a circle and the circumference of the circle is 2 pi. And every single equation in mathematics today has the, you could say an irrational constant, 2 pi is written right in it. It's in the Dirac equation. It's in the Einstein field equation. It's in every equation, 2 pi. Well, that's an irrational number. That has to be rationalized in order to reparameterize the plane with curvature. And that's the solution to the calculus. And it's also the solution to complexity, the complex plane. The complex plane is a mistaken hybrid, very useful. All of this is superpositional because only the linear numbers are computable. And therefore, any solution you get to a spherical or circular problem where you're forced to use the calculus and or complexity, both of which are required now, you must master calculus and you must master complexity or you can't understand the universe. That's ridiculous. However, it's valid. It's superpositional. We're using the derivative number system to solve an integral problem. Why don't you just use the integral geometry in the integral number system? I discovered how to do that. And that changes everything. That erases Euclid as number one kingpin. It also erases Einstein. I am at the top now. I discovered the answers. So that's what conjugality offers. The solution to the Einstein unification sequence, which he died frustrated because he didn't achieve it. I achieved it. So that's the nature of conjugality, and that's 15 minutes. I'm sorry, we'll have to come back in another video I'll try to produce. Keep looking up. We'll be right back. Thank you.